Okay, I think we can start now. Okay, welcome everyone to this edition of NG Asia Meetup. We are excited to have you with us today for a session that divides into one of the most important topics in modern web development, Angular server-side rendering. We're honored to welcome Alain Chautard as our speaker. Alain is a Google developer expert, Microsoft MVP, Cypress ambassador, and a globally respected Angular and React educator. He's known for breaking down the complex topics and helping developers build a fast, scalable, and modern application. Today, Alain will walk us through the fundamental of Angular SSR, why it is a matter, how it works, and how you can start using it to improve performance and the user experience in your Angular app. Let's give warm welcome to Alan and dive into Angular SSR. Alan, you can start.
Okay, hello. Thanks everyone for having me for this talk. So I'm going to start sharing my screen and you should be able to see my slides now. And so yeah, we're going to talk about server-side rendering, which is probably one of the most most up and coming topics in Angular, something that the Angular team has invested a lot on in the past couple of years. And so it's been evolving very quickly. There's a lot of new features coming to with Angular 20 very soon for server-side rendering. So yeah, definitely one of the big topics right now in the Angular world, and lots of good things going on in that area. So my name is Alan, as you just introduced me. I'm a Google developer expert in Angular and Google Maps. Started with Angular a long time ago, back in 2011, is when I really started getting into AngularJS. And then over the years, started my own company, angulartraining.com, where I do consulting and training. And I've been speaking at conferences about Angular or front-end technologies all around the world. So that's me. So server-side rendering, in order to illustrate how it works and what it does, we're going to use a real app. Well, real is it's a store that I use for many of my demos. So store.angulartraining.com. And it's a live website, but it doesn't really work in the sense that you cannot buy things there. It's like a mock website that I use for training. And so it has all of the features you could expect from an online store. You can add items to a cart, go to a cart page, go to a checkout page, and all of these different things. So there's a few different pages, there's a form, there's few different features like that. And so we're going to use it as an example to test server-side rendering. So the first question we might ask is, why should we even consider server-side rendering? Is it worth it? Is there any good reason to even think about it? And so before getting into that, it's important to remember, how does regular client-side Angular work, right? What happens when we load an Angular application in the browser? And so there's a bunch of different steps, right? You navigate to a web page. That web page is going to make an HTTP request, get some HTML as a result. And the HTML in an Angular app, as we know, is almost empty, right? It's just a body with the tag for main component, and that's pretty much it. And then it downloads the JavaScript, which is the real Angular app. So there's more stuff going on here, CSS. And then all of that code, once it's downloaded, it has to be parsed by the browser. It has to be interpreted. And then Angular takes over, builds the HTML DOM structure from that JavaScript code, displays the UI, and then starts loading the application. So the application starts doing its thing, meaning HTTP requests are going to happen from our services and components, updated them accordingly. And at that point, after all of these things happen, our page is fully rendered. So I described it in a way that sounds very slow because there are so many steps, right? But we know that in real life, this actually happens pretty quickly. Applications load pretty fast, and it's not that slow. But still, all of these steps have to happen before our page is fully rendered in an Angular application. So this is the app shell that I'm talking about, right? The index HTML, when we use an Angular app, is going to be our app root, which is our app component, the scripts that load our code, and that's pretty much it. So that's what gets loaded initially, and that's going to end up building the entire UI in the browser. So we can use tools to see if our application is fast or slow. And one of the best tools we have available for free is Lighthouse. Lighthouse comes with Google Chrome, so you have it in your browser right now. It's under the Performance tab, and you can run a Lighthouse audit very easily by just going to Lighthouse and running the audit. So I'm going to do it now to show you what it looks like, and we'll take a look at these different metrics and what they mean. Because the main idea of SSR is going to improve performance. So that's something we're going to use to improve performance. And so if we want to see an improvement, the first thing we have to do is look at the current state of things. Are we fast or slow right now? What are our numbers? And then we can see if we are actually improving. So I'm going to follow these steps. I have this repo available. So if anybody watching this wants to follow the steps on their machine as I do it, you can go to bit.ly/ATSSR repo. It's going to be a GitHub repo that you can check out and then run npm install. And so I'm going to follow these steps here. I'm going to build this project. So I have my code in my IDE. I'm going to open a terminal. I'm going to build it. npm run build or ng build, that's the same thing. This is going to compile our code for production, which, as you probably know, creates an output in the dist folder. So if I go to that folder, that's where we have our production index HTML and everything that goes with it, the main JavaScript, the polyfills, and all of that. So now I want to serve this production code. I want to run it locally on my machine. So I'm testing the real thing. I'm testing the real JavaScript Angular application for performance. So in this project, I added a specific command for that, which is npm run serve build static. So it's just going to start a basic HTTP server inside that dist folder. So I'm running the production code really, but locally on my machine. So let's run that command here. Copy and paste, copy, paste, and run. So this compiles my app. I can now open it in the browser. It loads, and that's my production app ready to be tested, ready to be validated. So if I want to get insights on performance for it, I can right-click, inspect, and here I'm going to go to performance. I can clear all of this. And here you see there's a record button. So if I click, I got it wrong. Performance is different. Lighthouse is the tab I'm looking for. I go to Lighthouse, and Lighthouse has several different options. So what do we want to test? I want to test performance. I want to test best practices. I could also test accessibility in SEO, but for the purpose of this talk, we're going to focus on just performance. And you can test in a mobile form or desktop. So I select desktop. Then I click my button, analyze page load. And when I do this, Lighthouse is going to load the application a few times and test different things. So it's going to measure how much time it takes to download all of the code, render something on the screen, how much time it gets to get everything rendered, everything. And we get that report at the end. Just takes a few seconds. So it's still doing it. And so, yeah, the score in the end is not great. I get 72 on performance, 78 on best practices. And if I scroll down a little bit, it's going to tell me that I had a blocking time of 420 milliseconds. So that's the amount of time it usually takes to download, the resources needed to display the application. So the JavaScript, the CSS, and all of that. We have metrics on the first contentful paint, the largest contentful paint. These two mean the amount of time it takes to get something interesting on the screen. Because initially, as we see down here with the screenshots, we had a blank page, right? We download an empty index HTML, and then we see things loading little by little. We see our components showing. We see the images showing up. So all of that is taken into account and gives us a score. And that score is not super high right now. So it's not super high, and it tells us why we get a penalty really in terms of score. And one of the problems that's highlighted here is that we have 7 layout shifts. And a layout shift is when things are displayed on the screen and then they move to a different place. Which, of course, when we load the application here, because Angular is building all of that DOM from scratch, we have one component showing up, and then we have another one, and then another one. So things end up moving around quite a bit, right? The text moves up and down, then the images gets inserted and move the text down a little bit more. So this is shifting the layout on the page, and it is a performance problem because if you're using a slow device, like if you have an old mobile phone or if you have a slow computer, all of these layout changes are going to be expensive and are going to make things slower and the user experience not as interesting. So we want to get rid of that. So now we have a basis to start from. We have a score of performance, which is 72, and we know that we have a layout shift issue. So what's next? So yeah, this is the explanation of the layout shift, which is basically what I just described, right? This has a bigger impact on mobile devices. Computing a new layout by moving things around slows things down, uses more battery power, more CPU, and it's usually not great for phones. So if instead of doing client-side rendering, we use SSR, we use server-side rendering, what's the difference? The difference then is the following. So this is the same timeline as before, right? Of all of the things that have to happen in an Angular application. The main difference between this and what we talked about before is that when you use server-side rendering, the HTML and CSS that you download initially already have the page fully rendered. So your page shows up 100% ready right from step 2, before we download JavaScript, before we parse that JavaScript and interpret it, and before Angular takes over the DOM and control future updates. So the user gets something in a ready state on the screen a lot faster. And just, as a reminder, before page fully rendered was the last step. If you do regular client-side Angular, all of these steps have to happen before the page is fully rendered. When you switch to server-side rendering, your page is fully rendered instantly. And so that changes a lot of things because as you can imagine, the reason what's this is going to enable is faster loading time, right? Server-side rendering is going to get your page loaded almost instantly. It also enables caching, right? Because your server can create a page and cache it, and then the browser can do the same. So if your pages get cached in the browser and on the server as well, it's going to be a lot faster to load or reload a web page the next time. It also helps with search engine optimization, SEO. Of course, a pre-rendered page is going to be faster, and when a web page is faster, it tends to score more points from an SEO perspective. It's always seen in a positive way if your web application is faster for search engine indexing. And of course, in terms of pure performance, so other than speed, all of the scores we just saw, first contentful paint, the layout shift, and all of that, they all get improved when you use server-side rendering because you load the entire page right from the start. So the layout doesn't switch anymore. All of the components are in place, all of the text is in place, and so there's nothing is shifting anymore. Same thing, the content is already there. So the time to wait to get that content displayed on the screen is almost zero. So this automatically boosts your performance. So if we want to test SSR, if you want to start using it, how do we do that? If I want to enable SSR, the first constraint is to have at least Angular version 17. When you use at least Angular version 17, and if you start a brand new project, Angular CLI is going to ask you, do you want to use SSR or not? And if you say yes, your project is going to be set up for that by default. Or you can just use ng-new-ssr, and this creates a brand new project with server-side rendering. Now, if you have an existing project like mine, and you want to use SSR with it, you can just run ng add at Angular/SSR. And just by doing this, just by running that command, Angular is going to change your project config, add all of the files and dependencies needed, and then you have server-side rendering enabled. And this can happen in a way that doesn't even require extra work on our end. You don't need to change your code or anything. It would just make everything SSR compatible. So I'll give this a try. I'll add SSR to the project and we'll take a look at what happens when we do so. So ng add Angular SSR, we'll see what are the changes, we'll build our project and we'll serve it again. So let's go back to my console here. I'm going to stop that server and I'm going to do ng add at Angular/SSR. So this is going to do the work of installing Angular SSR. So doing the npm install. Yes, I want to proceed. Installing those packages and updating some files. So if I scroll back up, I see the following. I wanted to show you the updates that were made and I don't see them here. So good thing I had a slide for that. So what gets created is a main server.ts, an app config server.ts, a server.ts. So these three files automatically get created by Angular for us. And then of course we have new dependencies, so package JSON changes, the app config changes, and the Angular JSON, which is our main Angular config, also gets updated. If I go to my project, we'll see all of these things. So app config server, main server TS. So all of these things got auto-generated. And we basically don't even have to know about them, I would say, because we don't have to change those files. It just it just available and happens that way, and we can use it as is. And so yeah, these are our main changes. Now it looks like my npm install failed in that scenario. And that's what happens when you do live demos, right? There's always something interesting going on. I might have just, because this was still based on Angular 17, I might have some discrepancies in terms of version numbers here. So what I'm gonna do is just update to something more recent. So I believe just an ng update would fix it. Not ng update, npm update. To get those versions, to use something a little bit more recent. It's going to take a few seconds. But yeah, as you can see, the changes in terms of config are very minimalist. And another thing that happens is that in our application config, we'll see this provide client hydration option. And what hydration is, it's something related to the fact that when we use SSR, we download the HTML initially, right? We download a page that is fully rendered, which means the DOM is created already before Angular gets loaded. And so Angular is going to take over that DOM a few milliseconds later. And then it has to add its event listeners and control the updates of the DOM that are going to happen later. So that process of Angular taking over the DOM and updating it in the future is what is called hydration. So it's basically Angular taking that static HTML downloaded from the server and turning it into our dynamic Angular application. So this is called hydration. And so to have that hydration in place, this provide client hydration option is automatically added when we add SSR, so we have it by default, right? And this is important because in the past, so before Angular 17, if you did server-side rendering, what would happen is that when Angular was loading, instead of using the existing DOM, it would just destroy it and recreate it, which of course doesn't seem to make sense, right? If you downloaded an app from a server, you want to use it as is. You don't want to destroy the HTML and recreate it. In the past, that's what happened, but now with modern Angular SSR, we have hydration that just takes over the existing DOM, and it's a lot better. So let's see if my npm update completed, and it did. So looks like we should be good now. Yeah, I don't see any more dependencies missing. So I should be ready for the next step, which is going to be to build our code. So I'm going to build it just like I did before, but now hopefully we'll see something different when I build that code, since now we have server-side rendering enabled. So it takes a little bit longer, and that makes sense because now we have server-side code, we have client-side code, and also if we go to our dist folder, you'll see that now we have a server folder, and in that server folder we have quite a few different things. So we have some server-side code. We still have a browser folder where we have our index.html still and main.js and everything. But what is different here is that if I open the index.html, it's not just the root, the app root component. It's everything now. Now, this is a little bit hard to read because, Angular is always minifying our code and obfuscating it, but that's my entire web page here. This is the entire HTML. So this index HTML now has everything pre-rendered. So when we build an Angular server-side app, all of the HTML is pre-rendered in the index HTML. And that's powerful, right? Because the compiler is just pre-rendering everything. And this is true for my main page, for my index HTML, but it's also true for the other pages. Meaning, if we look at our structure here, you'll see that I have a cart folder with an index HTML and a checkout folder with an index HTML. So all of my different routes have been pre-rendered, and Angular generated one index HTML for each of them, pre-rendering that specific page on the server at compile time in our case. So let's run that code. So now that I have this, I'm going to use a command to actually start that server. So npm run serve SSR ngx training. This command, I believe, gets automatically generated. A few commands got added when we did SSR, and so this one is just going to run my server as a Node.js application. So the command is node dist ngx training server.mjs, right? Just running the server that we got from our build. So let's run that command. So we start a server on localhost 4000. I open it. It shows up here. And if I refresh, well, we pretty much don't see anything, right? Because it's instant. So the HTML, there was no layout shifting, there was no blinking or whatever. It just, the page is here. And so now we can test if there's any improvement in performance, right? So I'll go back to Lighthouse and I'll do the same audit as before. So running the Lighthouse audit on that server-side rendered page. And it's going to take a few seconds, but then we'll see if we get an improvement. And just as a reminder, before, for my client-side app, I got 72 in terms of performance. And now for the server-side equivalent, the code is the same, right? We didn't change anything in the code. All we did was enable SSR. And with SSR applied here, I get 80. So I got an 8-point improvement from 72 to 80 in that scenario. Now, it does say that some of my Chrome extensions have affected this run, and I should try in incognito mode or without extensions for a better score, which I think is true because usually I was able to get 99 in performance here, which was perfect. So I might have that issue, but you can see that the layout shift is now close to 0 because we get everything loaded right from the start. So everything is a lot faster. Speed is also a lot faster. 0.6 used to be, well, it's 0.707, but again, it's localhost, so we don't have to go through the network and everything. If it was online, it would be a much bigger difference between these two numbers. So yeah, we saw an 8-point improvement out of the box just by using SSR. And we see the layout shift is now almost non-existent. Just that initially we have nothing and then we have the entire page. So yeah, that's really the benefit we get. And I did a comparison here of runs that I did before when I prepared this talk. Before SSR, performance was 88. And we see the layout shift happening. After using SSR, I was even able to get a 100% in performance, and everything was just displayed right away. So yeah, that's really the best, the seller point, right, for server-side rendering. It's gonna improve performance always, because at the very least, you get rid of that layout shift, and you get rid of the initial time to paint the page. So all of that, of course, gives you a much faster experience. So yeah, I showed you that the structure is now different. When we do SSR, we have a browser folder, we have a server folder, we have code for all of these things. And of course, one of the constraints when you want to use SSR is that you need a Node.js server to run your project, which was not the case before. If I have a regular Angular application, I can just take my files, put them on any HTTP server, and it works, right? I don't have to do anything else. But with server-side rendering, we need to run a server script using Node.js. It means we need to host that code on a Node.js server. So if you want to do server-side rendering, that's something to have in mind, that you need to host your app, your Angular app, on a Node.js server, which may or may not be the case for you right now. But if you want to do SSR, you'll have to do that. Let's check if we have any questions, maybe, before going on. So,
Yeah, we have a question from Nicholas.
okay.
Okay. Do you think it is necessary to use SSR for back offices or internal apps?
Yeah, that's a very good question, because as I mentioned, many of the benefits of server-side rendering apply to SEO, search engine optimization, making things faster and all of that. Which means if your application is on a private network, back office private app, SEO of course does not apply to that, but still, if it's a massive application with lots of JavaScript, you might benefit from pre-rendering and getting the initial landing page HTML being displayed faster. So I would say it's something to test, right? You can run a test, do like the performance loading thing that we did with Lighthouse, get a score, and see if the score is really bad, then SSR could help by at least solving the initial page time load and not having any layout shift. It also depends if your app is supposed to be used. It could be an internal app, but something you use on phones. And if you're supposed to use it on a smartphone, you don't want the layout shift because it's going to slow things down, it's going to drain your battery and all of that. So if battery usage and performance of that private app is still important, then SSR could also help with that. So yeah, it depends. It's less likely that you would need SSR for a private app or something running, on a private network. But still, it can boost performance. So to be tested with Lighthouse and then decide if it makes sense or not, I would say.
Okay, we can continue.
Perfect. So I mentioned that when we do SSR, we have to use Node.js as a server, right? That's something that we can't work around it. It's really part of the deal, part of the process that we need that. Are there any other differences, any other things to be aware of? So for the most part, our code can remain exactly the same. We don't need to change anything in our code because, right, it's just the server rendering that code and displaying it. And so it's just generated on the server side. That said, of course, there are things that the server is not going to be able to do, because if you're using JavaScript objects like window or document, navigator, location, so all of these things are browser specific, right? You can only access the document if you have a DOM, and that means you are in a browser. You can only access the window if you are in a browser as well. The location, the navigator, if you try to get the geolocation of the user, that's also going to be something that is browser specific. So all of these APIs, they are available in the browser, but they're not available in Node.js on the server side. So for this, we have a specific new lifecycle hooks that were added to Angular after render and after next render. And the idea is to use these lifecycle hooks in your component whenever you need to manipulate these native browser APIs. And that is going to tell Angular to not run this code as part of the SSR rendering, but only when Angular runs in the browser. So that's one little exception that we have to make when using server-side rendering. That's the only change really we would have to make in our code if we use these native APIs from the browser, like document, window, navigator, location, and all of these global JavaScript browser objects. And so you have two options. So after render is going to run after every render. So kind of like a NG on changes, if you will, for inputs. And after next render is just going to run once after the first render. So more like an NG on init. So if it's something you need to do once, you would do it after next render, like NG on init, and it's going to run that code on the client side. If you want to run every time there's a change, then after render is the hook you want to use. But again, this is only if you want to use these native APIs. If you don't use those, you don't need to do anything different in your application. So now you're probably thinking, okay, SSR could be interesting, but I don't have the option to use Node as a backend. Let's say your company is using Java or .NET as a server, and they don't want to add, Node.js in the mix. They want to stick with the architecture that you have right now. So there's something we can do to still get benefits from server-side work without using Node.js. And that's what we call static site generation, or SSG. So what's the difference between SSG and SSR? When we use SSG, what we do is we're doing pre-rendering. And the pre-rendering is what we actually saw in the build process, right? When I ran ng build earlier, we saw that we got static files, index.html, for every route in my application. So at build time, when we compile the app, Angular is going to pre-render all of these pages. And so if I wanted to use those static pages that were built at build time, I could do that. And so I would then benefit from that pre-rendering, even though, of course, it's done at build time. So between the time when I compile the app and the time it gets deployed to production, the data might be very different, the data that we want to display. So that's something to keep in mind, right? That we might have a little bit of discrepancy or delta between our app that we pre-rendered a long time ago and what we render in production. But the good thing is that you still get the benefits of having that frame of the application fully loaded with the entire HTML displayed. This is also a good option if if your app has a lot of static content. So if you have a lot of things that don't get updated very often, it's just text that remains very static, or stuff that would require a build to get updated anyways, in that case, SSG is just perfect because you can rely 100% on those pre-rendered pages that are built at compile time and use them. So SSG is a good middle ground, right? Between a full client-side Angular application or a full SSR application. SSG is kind of in between, where you get benefits from the server-side rendering, meaning that your HTML is pre-rendered once at build time, and you can use that HTML to speed things up. And you don't get the downside of having to use Node.js if that's not an option for you. So SSG is a good thing and pretty easy to use. So if I look at my code, so yeah, I showed you these pre-rendered pages already. Just gonna highlight them again. So I have one index for my cart route, one index for my checkout route, and one main index HTML for the landing page. So in my case, my router config has 3 different routes, as you can see. And so Angular SSG pre-rendered 3 different pages as a result. So it read that config and decided to pre-render all of these pages and generate the HTML for them. Now, of course, Angular can read our config and guess, guess what has to be pre-rendered, but there would be other scenarios where Angular doesn't know what to do. Like if you have parameters in your routes, Angular would not know which parameters to use to pre-render things. For instance, if I have a product page and I want to pre-render product 1, product 523, just pre-render a bunch of products that I know people want to see, and we want to make sure we have that page pre-rendered to make it faster. So in these scenarios, we can help Angular, and that's something that's going to change very soon. They're going to make it even better by giving us a way to completely customize the approach and be able to tell Angular, hey, this is how you get the list of all of the routes you have to pre-render. This is how you get the IDs of all of the different params you can use. Yeah, the basic behavior is to be able to provide a file. And in that file, so in Angular JSON, you would say discover routes false, which means Angular, do not discover the routes by yourself. Instead, use my config here with a list of routes to pre-render. And so in that scenario, I decided to list just 2 routes to pre-render, /, which is my landing page, and /cart, which is a cart page. And here I could list as many as I want, right? I could have 1, 2, 10, including routes with parameters and everything. So I just take over and I tell Angular what I want to pre-render. So that would allow me to customize that behavior. So yeah, that's always pretty powerful. And yeah, I can give this a try. Let's see, I'll go to I can just use npm run build static because I already compiled my code. So I'll stop the SSR server here. I'll go back to my previous command to build static, which runs on port 8080. I can inspect, let's refresh, should be pretty quick. Yeah, only the images get reloaded here. So this is my SSG page, and we can tell because if we go to the network tab and look at what got downloaded when we loaded it, we see that the response was the full page already. So the HTML we got from the server right from the very start, the first request we made, downloaded the entire page with all of the data, all of the components already pre-rendered. So we can tell that from here. Another interesting thing that is very powerful is that not only do we get the data, not the data, the HTML, we also, if we scroll down a little bit and go to the very, very end, you'll see that there's a script with an ID of ng state of type JSON that's at the very end of that HTML. That is a JSON file. And that JSON file is actually a cache of the HTTP request made by that application. Because when that Angular application loads, it makes a request to a server to get all of these products. And what SSR does is that because it made the request on a server already, it said, well, when Angular is going to take over, it's going to try to make that request again. So let's give the data for the HTTP client to use as a cache initially. So we have the URL, we have the status of the response and everything. And so when the app loads in the browser, instead of trying to re-download that data from the server, it's going to use the data that was cached here in the index HTML. So Angular really tries to make things as, as smart and as powerful as possible. So even our HTTP requests that got pre-rendered and pre-run on the server side are cached in here. So the HTTP client doesn't redo those requests in the browser, at least the first time, right? When hydrating the application for the first time, it's not going to redo those requests, but use that cached data instead. So lots of smart things going on, very, very powerful stuff that we have with server-side rendering by default. So yeah, you can see that my website is working. I don't have any Node.js server in that scenario, and I'm still using pre-rendering, right? I'm still using that server-side generated code. So that's what we call SSG for static site generation. And so yeah, that's all of the topics I wanted to cover today, all of the things that I wanted to touch on. Do we have any other questions?
No, I hope it will be on a comment, um, or maybe, but right now we're only one question
Okay, no
ready
problem.
to answer. So, um, that's it.
So that means we're all nice and clear.
Yeah. Yes.
Perfect, perfect. Okay, so yeah, if we don't have any questions, I just wanted to mention the Angular certification program. So that's a certification I started with a team of other GDEs 5 years ago, and we have thousands of developers certified all around the world. It's not an easy challenge, right? It's gonna test your skills. There's different levels of certification too, from junior to senior. And so, yeah, I suggest anyone to take a look, give it a try. This certification is used in several countries for companies to recruit people or promote people internally. They use that as their benchmark already in Europe, in Asia. So yeah, if you want to take a look, just so you know, certificates.dev/Angular, that's where you're going to find all of the info about that. If you have questions about it, you can always reach out to me on LinkedIn or social media or anywhere. And I wanted to show you, so my blog, the URL is here. The slides, if you want to access these slides and the code examples and everything, the URL is here as well. And yeah, on this last slide, I wanted to mention Frontend Nation, which is a free conference that's going to happen early June. It's all about front-end frameworks, so Angular, React, Vue, and others. And it's a free event online, so anyone can attend and watch these talks for free. So yeah,
Yeah.
that's everything I wanted to talk about.
Yeah. Okay. I'll definitely share all things in my LinkedIn and x.com. So it will be helpful for many developers in Asia. So that's great. So yeah, we can finish. Thank you, Alan, for a clear and insightful introduction to Angular SSR, from its benefit to how we can start using it. Today's session give us a strong foundation for building faster, more optimized Angular apps. And a thanks to everyone who joined us on YouTube, whether you are watching live or catching the recording. We appreciate your time and interest. Be sure to connect with Alan and the community as we continue learning and growing together. We will see you at the next NG Asia Meetup. Until then, happy coding. Thank you.
Thank you. Thanks for coming.
Okay.